Hello students, today we are solving the again numerical problems of module 5, but it is a second part, and in this part we have dealing with the gradient. Now what is the gradient? The gradient is a function. Gradient the gradient is a function, and fxy is a two dimension, is defined as in a two dimension. It is defined as that grade of any function is delta fx. There is no dot product, no cross product. It is a simple multiplication. So as we know that the delta is what? Delta is d upon dxi plus d upon dy. So when we are going to multiply this function with this delta, what we will get? We will get del f upon del xi plus del f upon del y j. If it is in the three dimension, then one thing is also come here, plus del f upon del z k. Okay. Now this is the gradient of so the gradient of a function is a vector field, because I j k came, that's why it is a vector field, and it is obtained by applying a vector operator delta to the scalar function fx. Such as vector field is called the gradient vector field. Means if I want to represent that the something which is in a scalar, and we want to show its flow or its direction of its flow, then we have to find out the gradient of any function. Like suppose that you're having a one rod and you are heating that rod. So temperature is a scalar quantity. Near to the candle or near to the burner, the temperature of rod is very high, but at the far away from that, the temperature is very low. So temperature is a scalar quantity, but what is the variation of temperature? It is a one type of a vector quantity. So such type of a quantity means flow of the temperature or variation of the temperature is shown by the gradient only. So temperature, suppose that this fxyz is your temperature, and you want to be show the variation of the temperature in the rod. So what you are going to be do, you have to be find out just a gradient of that temperature, which is a vector quantity. Why it is a vector quantity? Because it shows that temperature at the one end, which is near to the burner or near to the candle, is very much heated, and the temperature at the second end, which is the far away from that burner or a candle, it is not too much heated. So it shows that the flow of the temperature or variation of temperature, that near the burner end is temperature is high, and far away from the burner end is very low heated. Okay. So such type of variations are shown by the gradient. That's why gradient of any vector field is a gradient of any scalar field is a vector quantity. Now how to solve examples or a numerical problems of a gradient? Suppose that a function is given here, and you have to find out the gradient of that function. So what to do? Nothing, just apply a delta operator on that function, as and we know that delta is d upon dxi plus d upon d upon dy. So you just simple multiply it. And so when you are applying the function on that, so at the place of function, what is the value is given? X plus x square. So you have to substitute the value of that. Now differentiate this value with respect to s. As we know that del upon del x is the value is 1, and because y is not depending upon x here, so that the value becomes 0. Similarly here x is not depending upon the y, that's why the derivative of del x upon del y is 0, and here 2y. Now it is in the I direction and it is in the j direction. So the vector of this scalar quantity is what? I plus 2yj. So I think so it is very simple for you. So this example is only for the two dimension quantities. If there is a three dimension, suppose that z is plus z square is also given here. So what it will become here? Plus del f upon on del z. Okay, multiply by the k, and you have to put the value of that function is also here, that in the form of z also, and then you can calculate it. I think so it is not big problem for you people. Now suppose that you have to be find out the again you have to be find out how the function. this scalar, the vector of this scalar function or gradient of this scalar function. But what is given here, that it has no y dependency and it is a linear in x. So its gradient, how you can calculate the gradient? Again you are you have multiply this function with del upon del xi plus del upon del yj. So you are getting this values. Now differentiate with respect to s, what we will get? We get L what? 3i. Okay. And when we are differentiating this del upon del y, because it is depending upon x now, that's why I this value becomes 0. And when we are differentiating 3x with respect to s, we get the 3. So 3 multiplied by I is 3i, and this there is a no x, no y, no z, nothing is there. That's why when we are differentiating with respect to it, this value, this is the constant value, so it becomes a 0. So now again we are differentiating this equation. So as we know that there is a no y dependency, that's why this term becomes 0. So what we are getting? We are getting 3i. So there is no component in the direction of y, only in the component of in the direction of x only. So the gradient of this function is equal to the 3i. Okay. And now you have to be solve this examples, and give me as a assignment any two example you can carry from this six examples. Okay. No problem if you are solving first and second, then only no problem, second third then only problem. So you have to be just choose any two from this six. Okay. Now next thing is that next is what the directional derivative, how to calculate the direction. So as we know that a unit vector shows the direction of any vector. So unit vector is denoted by n cap. So n cap multiplied by the del f, it shows the direction of, it shows the direction of any gradient, or we can say that the vector quantity, because del multiplied by f is a vector quantity. And what is the significance of directional derivative? The directional derivative shows the rate of change of any a vector function, and its rate is maximum in that direction. Which direction? In n direction. Okay. So we are going to solve the next problem. What is the problem? Let us find out the directional derivative of f x, and what is the value of fx x square y z in the direction 4i minus 3k at these points. Okay. Now see here, there are 3 x y z, 3 points are given, so that we have to find out the directional derivative in three direction x y z. So what we are doing first we have to be calculate the value of n. And what is the n? N is actually a scalar quantity, and it is shown the magnitude of any vector, so that we have to find out the magnitude of that vector. So what is the magnitude of this vector? It is calculated like that. You know this thing that how can we calculated the magnitude of any vector. So what is the magnitude? It will be it is come equal to 5. Now we multiply this directional derivative, or we find out the unit vector of the directional derivative for I is thus n bar is equal to 1 upon 5 I by 4 I minus 3k. Okay. So first you find out the gradient of this function. So for finding the gradient of a function, we differentiate this function with respect to x y z and with I j k, and we get this value. After that, what we will do, that we will do just simple thing, we multiply the value of n cap with the del f, and when we multiply n cap, this is the dot product. So don't forget this thing, that when we multiply the value of n with the del f, it is a dot product. Because of that, because the direction when we are multiplying with the direction is also a direction derivative is also a vector quantity, and sorry, direction derivative is a as a scalar quantity. So we have to be multiply these two things by the dot product only, then only we can get a scalar quantity. Otherwise again we are getting a vector quantity. So 1 upon 5 4i minus 3k is the value of n cap. So we substitute here the value of n cap. After that we substitute the value of del f and find out the dot product of it. So when we are finding the dot product of it, what we will get, and we will get this equation. but we have to find out this direction in or at which point, at 1, -1 and 1. So at the place of x, y, z, and or here x, y, z, we have to substitute the value of x, y, z. So what is the value of x here? At this point 1, y is -1, and z is 1. So we substitute the value of x, y, z in above equation. So by calculating this equation, what we will get? Minus of 1. So the directional derivative in at point 1, -1 and 1 is minus of 1. So similarly, you have to be calculate the directional derivative of this function in the direction of j at point 1, 2, 3, 4, and submit it by tomorrow. Thank you very much.